This question came in 2001 for EC gate for 2 marks. The question is, the transistor shunt regulator shown in figure has a regulated output voltage of 10 volts. And as it says, it's a transistor shunt regulator because the transistor is in shunt with the output when the input varies from 20 to 30 volts, which is mentioned here. The relevant parameters for the Zener diode and the transistor are: the Zener breakdown voltage is given, which is 9.5 volts, and VBE, the base to emitter voltage, is given 0.3 volts, and beta, common emitter current gain, is given, which is 99. Now neglect the current through RB. RB is here. Then the maximum power dissipated in the Zener diode and the transistor R. Now, in order to find the maximum power dissipated, we have to check it for the maximum input voltage, so that there is maximum current flowing and yet the output voltage is fixed, which is 10 volts. The voltage is not changing even if we give 20 volts or 30 volts, but the current flowing will increase if we give or consider the maximum voltage. Hence, we will take 30 volts here to check the power dissipation. When it is 30 volts and the output is 10 volts, in fact, even here it will be 10 volts, the amount of current flowing here will be, let's say this is I is equal to 30 minus 10 over 20 ohms. This is in volts. This will be equal to 1 ampere. If 1 ampere current is coming, it has to actually go part of it through here, which is IZ, and part of it is IC. Now let's find how much is this current. Now one assumption we are given is neglect the current through RB, which means current flowing here to be taken as 0. So which means IZ should be equal to IB, and of course IB is related to IC, that is IB is equal to IC over beta. So in that case we can write this current I, which is 1 ampere flowing, this should be equal to IZ plus IC. Now we are already given IZ is IB, so let's just find that out here. This is 1 ampere. So we can write IZ is equal to IB, where IB is IC by beta. So let me write that here. This is IC. Now we can find what is IC. IC is equal to 1 ampere times beta over 1 plus beta. So IC will be equal to 1 ampere times beta is 99 over 100. This will be equal to 0.99 amperes. Now as we know, I is equal to IZ plus IC. If IC is 0.99 ampere, let me put this, IC is 0.99 amperes, IZ will be 0.01 amperes, which can be written as 10 milliamperes. Now we need to find what is the power dissipation, or maximum power dissipation in fact. So maximum power dissipation at the Zener diode will be Vz times Iz, which will be, Vz is given here, that is 9.5 volts. 9.5 times 10 milli will be equal to 95 milliwatts. So we found what is Pz, maximum power dissipation, maximum power dissipated in the Zener diode. Now let's find Pt. Pt will be equal to VCE times IC, which will be equal to, VCE is nothing but the output voltage itself, which is 10 volts, times IC is 0.99 amperes. This will be equal to 9.9 watts. Now we have both the values. So let's find which is the answer. Option C fits the answer, which is Pz is equal to 95 milliwatt and Pt is 9.9 watts. So the correct answer is option C. If you like the video, please give a thumbs up. If you haven't subscribed yet, please do subscribe, and thank you for watching.